Hello students. So today we have yet another very interesting problem from H.C. Verma, chapter friction. This is question number 28. Let's read the question statement. It says find the acceleration of the block of mass capital M in the situation of figure below. The coefficient of friction between the two blocks is N1 and that between the bigger block and the ground is N2. So here's the figure. Down here, let's first understand how the motion of the system will go, how the two blocks will move, and then identifying the forces and writing the equations will become a little simple. So as you look at this figure, there is this block capital M and this block small m, which is connected to capital M through a string which goes over these three pulleys, as you can see here. So if we try and understand how this system will move, why will it have a tendency to move in whatever way it is, see that capital M is kept on the surface. So gravity, as it tries to pull it down, there will be a normal reaction coming from the ground and will handle that up. So capital M as such has no tendency to move along the vertical direction, whereas small m, which has its weight acting in the downward direction like this mg, this mg will pull small m down, because of which it will create a tension in the string here, which I have called as T, and as you can see, the string being massless will have the same tension throughout its length till here. Yes. So this T will make the capital M block move towards right, because if you look at it carefully, this T as well as this T here, both of them are acting on capital M. If you look at it carefully, this pulley is essentially a part of capital M, and hence when this tension force T acts on the pulley, it is actually acting on capital M itself. So both the capital M and small m then will have a tendency to move. Small m will tend to move down. As it moves down, it will pull the string which it is connected with in the downward direction. As the string moves down, understand that because of the tension created and is acting on capital M will have a tendency to move towards right. So the system as such will look like this. We will have capital M moving towards right with, let's say, an acceleration a, and small m, because it is always in contact with capital M here, small m will also move towards right with an acceleration a, because it will always remain in contact with capital M as both of them move horizontally. Apart from this, small m will also have a downward acceleration, and we will try to find out that acceleration in terms of this a itself. Okay. So now as we have got an overview of how this system is moving, let's move on to the mathematics. Let's assume a few values and then try forming the equations. So let us assume that capital M moves with an acceleration a towards the right, due to which we understand that the length of the two horizontal parts of the string, it's a single string here, one single string that connects capital M with small m going over three pulleys. See that these two are the two horizontal parts of the string. Now as the capital M mass moves towards right, these two parts of the string will shorten down, their length will become short, because this pulley on the left which is a part of capital M, is moving towards right. Yes. So as the length of these two horizontal parts of the string becomes less, what will happen? All that extra length will go over here to this vertical string which is connected to small m, and this will make small m move down. So if the capital M mass is moving with an acceleration a towards right, the length of the two horizontal parts of the strings also reduces by the same acceleration a, and then because these are two strings whose length is decreasing by a, all that extra length will go down to the vertical string connected with small m and will create an acceleration of 2a in the mass small m. So small m will move down with an acceleration of a plus a, one due to each of the horizontal strings and horizontal parts of the string, and small m will move down with 2a. So through this we are able to connect the accelerations of capital M as well as small m, both along the horizontal and the vertical directions. Now Okay, so along with that we also know that small m moves horizontally with capital M with the same acceleration as that of capital M, which is a. Now what remains is drawing the free body diagrams of the two masses small m and capital M, and then writing their equations along the horizontal as well as along the vertical. So let us do that. First we will draw the free body diagram of small m. See that these are the forces acting on small m. There is a force of due to gravity mg. There is a force due to the tension in the string which is acting in the upward direction. Along with that, since small m is in contact with capital M, there will be a normal reaction acting on small m from capital M which will be acting towards right. And see that it is this N1 essentially which will make small m, the block M, accelerate towards right with an acceleration of a. Apart from this, it is also mentioned that the surface between small m and capital M is rough. So when small m slides down over capital M, a frictional force will come into picture, kinetic friction will come and will act on small m in the upward direction, and its value will be given by this expression. For the kinetic friction will be mu1 times the normal reaction that acts between capital M and small m. So this is the free body diagram of small m showing all the forces acting on it, and under the effect of these forces, a is the horizontal acceleration of small m and 2a is the vertical acceleration, vertically downward acceleration of small m. So using these forces and the accelerations known, we can write the two equations. Along the horizontal, we have net force is equal to mass into acceleration, which gives us N1 is equal to ma, and along the vertical, we have the net downward force which will come like this. Net downward force will be mg minus the upward force T minus the upward force mu1 N1. This should be equal to the mass of the block times its downward acceleration 2a. We can simplify these two equations to get this value for T. Now moving on to the block capital M, drawing its free body diagram. On capital M, these are the forces acting. One is its weight mg. The other force will be the normal reaction acting on capital M from the ground on which it is kept, vertically upward. Apart from that, since capital M is accelerating towards right, understand that there will be a frictional force, kinetic friction acting on capital M, which will be given by mu2 into N2. Okay, along with this, one more important thing. Since this pulley on the left side, we have seen three pulleys in the above figure. This pulley on the left is directly attached to the mass capital M. It is essentially a part of capital M, which basically means that whatever force acts on the pulley acts on capital M indirectly. Now what are the forces acting on the pulley? Since there is this string going over the pulley, the string will create a horizontal force of tension T and a vertically downward force of tension T, both of which will indirectly act on capital M. So we have to consider these forces acting on capital M when we write the equations. Apart from that, there is this another tension T which is acting on the lower point where the string is connected with capital M directly. So this T is also there. Then we have the reaction forces from small m. The forces that capital M exerted on small m, the block small m by Newton's third law will exert them back on capital M. So for this reaction force N1, we have a reaction N1 on capital M in the backward direction, this force. And for the frictional force that capital M creates on small m, we have this friction coming as the reaction force acting on capital M in the downward direction. So this finishes the forces on capital M, and we now know that under the effect of all these forces, capital M is accelerating towards right with an acceleration of a. There is no vertical acceleration. Along the vertical, net forces are balanced. Now we write the equations for the block capital M. First we will write it along the vertical because we know along the vertical the forces are balanced. So net force will be 0. So we have the net upward force, which is N2 only, equal to the net downward force acting on the block capital M, which if you look at carefully, there is this T, this mu1 N1 and this mg. All the three forces are vertically downward. So we will add them up on the right side, and then we can simplify this equation essentially by substituting the value of T from this above equation. So we get this relationship. Then Along the horizontal direction, when we try to write the equation, along the horizontal, capital M has an acceleration. So, the equation that we shall use is net force is equal to mass into acceleration, and the net force has to be taken in the direction of acceleration. So, net rightward force here 2T comes from this T and this T. Two horizontal T's are acting towards right on the capital M block. So, T plus T adds up to give you 2T. Then we have some leftward forces acting. There is this N1 and there is this mu 2 N2, the frictional force. So, rightward force minus the leftward force is equal to the net mass into the acceleration towards right. This becomes the fourth equation here for block capital M. And now all we need to do is we need to solve these equations to get our value of A. So, since the equations are a little involved, they are a little complicated, there are many terms here. In fact, if you just check, we have a total of 4 variables to be solved, N1, N2, T and A, 4 variables, but we have got 4 equations to solve them. So, slowly and steadily, stepwise, if you just solve, the calculations will be a little involved, but finally you will be able to get the answer. Here I have done all the detailed calculations, so if you want you can just refer to the steps here. This is the final answer that we shall get after solving the 4 equations above for the acceleration A of the block capital M. So, see that what is important here to understand is, one is the constraint relation, which is the relation between the accelerations of the two blocks. How is the motion of capital M and small m is connected, that is important. And then identifying the forces here will be one more extra important thing that you need to be careful with. So, if you want more such questions to be worked upon, do let me know. If you want any other question from the exercise of H.C. Verma or any other question from the chapter, do let me know in the comment section, and we will meet again with more such questions. Thank you.